let's get to the topic of today. Last lecture, we talked about relative velocity, and you saw how you can apply it in solving problems, similar to the one that you did for your quiz 5 or the example that last lecture I solved. To do a quick review, we said when we have an object AB or any object, we draw a line on it. AB, it's a rigid body. So the distance between A and B is not changing. But the whole body has a general motion, both rotation and also translation. Point A can move on a curve, point B can move on an independent curve, and these two can be totally different. Each point has a velocity and its own direction, as you can see, VA and VB. For us to do an analysis, we said we can set a point as a reference. It doesn't matter which point, depends on a problem. So if I fix point B to the ground, so just I visualize that I pin it to the ground, which it hasn't happened. But when we say I'm going to analyze point A with respect to point B, it means I fix point B. Or in mathematical term, we said we are setting our coordinated point B temporarily to do an analysis. And then simply you saw that if we have this setup, then I can write down VA now is equal to VB plus VA with respect to point B. And keeping in mind, this is all vectors. VA still is the original one, is this one. VB still is the original one, right? Nothing has changed. It is just the VA with respect to B that comes from this diagram, which in a vector format, you saw it can simply be written as omega cross R, right? The general formula that we use. And don't forget, always it is omega cross R, not R cross omega, because now we are talking about a cross product. And if we change the position of these two, we're going to get a different result. In order to avoid confusion, we agreed to show it as RA with respect to B, so everybody who is reading our solution can understand which R we are talking about. And omega, because we are going to have in a mechanism many other omegas, maybe. So why not write it as omega AB? And when we write omega AB, it means that we draw a line between A and B, and this line is rotating with an omega. We call it omega AB. This is what you saw last day. Now we are going to do the same analysis for acceleration. And it looks a little bit complicated, but it's not. It's just some extra terms. Let's do it together, and please follow along to make sure that you can understand everything. So I have a scenario, the same AB part, and point A is moving on a path, point B is moving on a path. Each of them has its own acceleration. And you know, this is a general acceleration AA, so AA on the picture, it can be a combination of AT and AN, right? Normal and also tangential acceleration. And again, keep in mind, this is all vectors, right? So we don't just add them. Why it has AT and AN? Because we know point A is on a curve, so it might have an AT and AN. Something like that, which if I break this A to its component, it's obvious that it's going to be like that. Let me draw that one better. And the same for AB. It has its own normal and tangential acceleration. Now, if we set the reference at point B. Okay, so this is what we are doing. Now we are analyzing A with respect to point B. Similar to what we did before. It means we fix point B, but imaginatively, okay? Because point B is free, we just for a moment, we set our coordinate at point B. And when we say we set our coordinate, it means we consider that point B as a fixed point for this very, very moment that we are solving the problem. Let's say this is X and this is Y. And to solve it easier and to understand it better, we imagine or we visualize that point B has been pinned to the ground. Now point A is simply rotating on a circle. And when something is pinned on a circle, it has and is moving on a circle, right? Like this one, it has two acceleration, AT and AN, right? So we know that the motion of point A is part of a circle. So it has AN and AT, which AN and AT, they have their own formula. So let me get rid of this ugly circle. So the formula, again, we saw in previous lecture that AT as a formula, it is alpha cross R. And AN also has a formula, it is omega cross R, right? And we show it like that. Or we said you may write it as omega cross R V velocity. Do you remember that formula? When something is rotating on a circle in a vector format, tangent acceleration is alpha cross R, and normal acceleration is omega cross R, or you can write omega cross R as velocity. And similar to what we did before, in order to avoid confusion, why not write AB here? So we are talking about alpha AB, and this is RA with respect to B. And this is omega AB, this is omega AB, and this is RA with respect to B. Therefore, this velocity is velocity of A with respect to B. Which velocity? If I move back one slide, this is this velocity that we talk about, right? This is the same setup. Everything is moving in a similar manner, but we are analyzing acceleration now. So this is what we know. And what about the now writing the acceleration relation? Oh, I'm going to write it down here. So I can write down, similar to velocity, AA is equal to AB plus AA with respect to B. Right? Exactly similar to velocity. Nothing has changed. Like the same letter, instead of V, we are just using A. Acceleration of point A is equal to acceleration of point B plus their relative acceleration. Except this time, we need to keep in mind that AA has two components, ATA plus ANA. And the same with AB. It has its own T and its own normal acceleration. What about AA with respect to B? This is what we saw on the diagram, right? It has its own tangential and normal acceleration. For now. Soon you will see in some scenarios, it has also another component. But for now, this is what we see, and this is what AA with respect to B is going to have. So, and again, keep in mind, this is all vectors. All right. So this is the general formula that we have. And we should be able to solve problems using this formula, using the IJ or graphically with vectors. I'm going to solve one problem to see how we can use this formula. But before I go further, if there is any question, please ask so we can clarify before moving to the next page and solve the problem. As you can see, it's super easy. It's just a matter of, and there is not actually a formula, right? They are all the same. We just need to know how to solve the problem. Let's solve one example and make sure that you can understand this topic. So I'll let you guys to read this example. This is a slider mechanism. By now, you have a good grasp of visualizing how this mechanism is working. You can even model it in the software that you have. And it is a common mechanism in engine. And this is what people call it a crankshaft mechanism, which we explained before. OB is a crank or crankshaft, and AB is the rod, and this block is the piston moving back and forth. So OB is moving with 10 radian per second. This is the information that we have. And also it has an acceleration, angular acceleration. So maybe the question should have clarified that it is clockwise. Let me write it down here. And omega OB, from the picture, we can see it is clockwise. So for acceleration should have been given by us in a question. Probably I forgot. And we want to find out the velocity and acceleration of point A. Keep in mind, always we start with velocity because we need some information for velocity before solving acceleration. Let's approach this problem together. Before I solve the problem, I try to draw some lines. So when I'm then solving the problem, maybe there is a less chance to make mistake for angles and everything. So one horizontal line here, and then one line from O to B. Also, why not extend it? So when we focus on the angle, we know what they are. And then one from this B to point A. Okay, so this is what we have. What else? And this angle, this is 20 degree. This is 60. This is the information that I have, right? If that is 20, then obviously this one is 20. And we know the angle for the other side of the triangle because some must be 180. So then that big angle has 100. But for now, let's keep it there. Point A and point B, these 2 points are my key points to solve this problem because I have some information for point B. I want to find out some information for point A. So why not I write down VA is equal to VB plus VA with respect to point B. And this is all again in vector notations, right? And now we convert these to I and J. So let's start with point A. VA, we know this mechanism when it moves, point A has to move on this line. At this moment, of course, it goes this direction. So this is VA. And it is horizontal. So it doesn't have any J component. So I write down this is VA I. And again, it can be positive or it can be negative. And we don't know the value for VA. But at least we know it is in I direction always. What about VB? So VB is on a circular motion, and we have the formula omega cross R. Its omega is minus 10K cross R. And so you saw from the example we solved last time, we set our coordinate, maybe X and Y. It's easier to solve with X and Y. So this is our X and Y at point O. All right, so this is X and Y. And based on this X and Y, I can find out the R. R is from origin O to point B. So let's draw that R by these green things. So therefore, this is R B cross O, right? Or just simply the coordinate for this point B, the vector, the R from point B. So using this angle, I can see this is 60 degrees. I can break it down to X and Y. That's easy, right? So if I break it down to X and Y, then can I simply write down here, it is, maybe let's convert it to meter, 0.5 cosine 60I plus sine 60J. I give you a moment to see if I haven't done any mistake. So this is the R B with respect to point O. And this is what we need for calculating velocity of B. Let's move all of this stuff a little bit over here. Or maybe why not bring in everything's over here. Okay, so, and then we have the other one, VA with respect to point B. So what is VA with respect to point B? It is, we have the formula, it is omega AB cross, and we know it is a K, right? But we don't know if it is positive or negative. We just show it as omega K. And it doesn't matter. We just assume it's positive, and if we get a negative number, then we find out that the rotation is negative. And now I need RA with respect to point B. So when we say with respect to point B, it means I need to set my X and Y coordinate here. Let's set them there. Then we'll go from there. So this is again X and Y at point B, right? And which R I'm looking after? This is the R I'm trying to find out. And that's R A with respect to B. Be careful for the sign, because if you make a mistake, instead of showing this vector in the opposite direction, then we're going to get negative values and everything is going to be wrong. Right? When we say RA with respect to point B, it means our reference is point B, and this is our vector. This is RA with respect to B. So what is this R? We know the length is 40, and we have the angle. So simply I can write it down as it is, the length is 40. Why not I write down 0.4, everything's in meter. And then, so it's going to be positive in X. So it's going to be cosine 20I. And it's going to be negative in J direction, minus sine 20J, right? And again, always try to find the component so to avoid the mistake. Do not rush solving a problem, because simply you can make a mistake, and I do it a lot if I rush it, and then everything is going to be wrong. the rest of the solution is going to be wrong. So this is what we then found. And as you can see, we just need to be patient. It's nothing really complicated here. And this is RA with respect to B. And please check to make sure that I haven't done any mistake and everything is in order. So hopefully, if everything is correct, then we have two unknown in this equation, which we can solve it. And I'm going to leave it here because you know how to solve it. You just need to do the I and J and get the I and J together. It's just an extra algebraic things, which you can do it easily. That's one method that we saw is straightforward. It's all I and J. It's a little pain and requires work, but it's straightforward. And another method that we said, always question ask us to do as a check, and it's a good thing. But of course, in future, when you solve problems for yourself, you pick the easier one. But for now, you need to learn both. Is just to show them in a graphical vector form. And then we use geometry like the law of sine or the law of cosine, or maybe other geometric way to find out the answer. So to do so, all we need to do is knowing the direction of the velocity. So VA is easy. Everybody agrees that VA is moving on this horizontal line. So what I will do then, I will draw a horizontal line somewhere on my page here. And I'll keep in mind that this is showing my VA direction. I don't know if it is going left or right, but I know at least VA is on this line. What about VB? So VB, we know B is rotating about point O. It is on a circle, and we know that this has to move on a line which is perpendicular to OB. Let me draw that line. Okay, so this black line, we know it has to have an angle of 90 degrees. So this is 90 degrees. This line, VB, is on this line. Right? Do you guys agree? B is rotating on a circle, so VB has to be on this line. So let me draw that line as well here. Maybe that line, or maybe you don't have to be exact unless if we don't want to do any calculation, hand calculation, and we just want to use our ruler, then we have to have tools to draw this angle correctly. So what is this angle? Again, looking at this triangle, then if 60 is the other side, then it means this guy has to be 30, right? So look at this triangle, O, B, and maybe let's call this point C. If 90 is over there, then it has to be 30. So at least I know this angle is 30. What about VA with respect to B? Keep in mind, this is what we are trying to do. We are looking at this equation and we try to find the direction for each of these components. Now I need VA with respect to B. VA with respect to B, so keep in mind, try to visualize when we say VA with respect to B, it means B now has been pinned to the ground and A is running on a circle, right? So in that case, then the VA with respect to B has to be perpendicular to AB, or has to be this line. Let me draw it better. So this angle is 90 degrees. And VA with respect to B is on this line. At this moment, of course it changed, but at this moment it's on this line. So I draw the same line here. Let's try to be close, maybe this one, okay? So let me write down, because I already got confused which one is which one. So the one that we just draw is VA with respect to B, and this guy is for VB, and this guy is for VA. Okay, so then we have three components, draw three lines and try to form a shape of triangle. This is all you need to do. And the information that you need for the angle and everything. So this line, do I know its angle? I should know. Let's see. If I claim that this angle is 90 degrees, this angle is 20 on this picture, right over here, look at point A. This is 20, then this line that we draw, this angle with horizon has to be 70 degrees. So it is 70. And then immediately I realize, because every triangle, the sum has to be 180, then if it is 30, 70, 100, it has to be 80 degrees. Am I right? Yeah. We are almost done. Now, start with the one that you know, you have some information about it. So the one that we know and we have some information about it is VB. Based on the direction, look at the omega for VB is clockwise. So we know VB has to be on the direction down. So then this is VB. Where is my VB? Okay. VB has to be on these lines, and the direction, we are certain that it is coming down. So this is VB. If we know one of them, the rest we can immediately figure out their direction, because we have to form this VA is equal VB plus VA with respect to B, right? So to have it right, then we immediately realize that, okay, then it has to be this guy, and this one has to be that guy. Or maybe let's use this guy. So this has to be VA, and this has to be VA with respect to B. Because keep in mind, this is the relation that we have. Right now, it makes sense because we start from this point. We add VA with respect to B. We add VB to it. We got to this point. We start and we ended it there. And VA is sum of these two vectors. Now, if you have that triangle, the rest, you know what to do, right? It's just you use the law of sine, which is straightforward. I can write it down maybe here. So you have three sides. One is VA, or let's just start with VB, because VB we know. VB, the value is 15, 0.1 multiplied by omega. Omega is 10. So it's give me 1.1. So this is 1.5. VB and VA, we don't know. VA with respect to B, we don't know, but we can find it out. So this has to be sine 70, sine 80, and sine 30. And simply from this formula, we can find out VA and VA with respect to B. So if I know VA with respect to B, right, if I know the value, then I know that there is this relation between them. VAB is equal to omega AB multiplied by AB, the distance between A and B. I'm just writing the algebraic equation. And this should give me omega AB. And the value that I'm getting from this has to be equal to the value or very, very close. Sometimes because we round numbers, we may get a different values. Okay, so two methods. And I'm sure it's super easy for you. I hope I didn't bore you. But it was important to follow because now we are going to do the same things for acceleration. And it's going to be a little bit messier, but we follow the exact same step. So I'll let you guys to take a moment, make sure that you haven't done any mistake anywhere, and you can follow everything. So please do not confuse these together. Maybe I should have done a better job. And let's move that guy there. And let's move all of these guys somewhere there. And while you're taking note, and these things, let's get rid of that so you don't confuse. So this is counterclockwise. And this one is there. So what we said is from the here we can find them, right? And I should have done a better job of managing the space here. So later you guys don't get confused. Okay, so now this is what we want to do. Oh, I like blackboards. I miss guys blackboards. So this is RA with respect to B, right? Let's see, we haven't missed anything. So this is what I wanted to show you. This is then is the sequence, right? This is method 1 and this one was method 2. From this method, after you do the calculation correctly, you missed the parenthesis here, bracket here. So after this, you should be able to find omega AB and also VA. And with the method above, also you should get the same value. So this is method 2 then. Okay, so this is method 2. All right, now it's clean and better, so you can follow it later. Let's do the acceleration together. All right, and hopefully there is no question. It seems you are quiet, and okay. For acceleration, we write down exactly the same relation that we had before. AA is equal to AB plus AA with respect to point B. And we keep in mind that they are all vectors. So far, this is what we saw before and nothing special about it. Then the next step is we know that acceleration has T and N components. We write them down. Let's look at A. And similar to before, again, let's quickly draw the lines. So A is moving on this line, right? And this is the other one. Everything digitally becomes slower when it comes to teaching. So this is the same setup that we had. So A, we know that is moving on a straight line. So it doesn't have J. Simply, it is AA, which we don't know the value, but we know it is I. We don't know if it is positive or negative. We assume it's positive and we just show it AA I. And we don't know the value. It might be 10, it might be 5, I, or whatever, is equal to AB. It has T and N component, TB plus NB. AA with respect to B, it has A and T component and N component. Now let's replace them. So AAI is equal to, look at point B. B is rotating about a circle about point O, right? So, and I write down the formula one more time here. So we know that AT has a formula of alpha cross R and AN has a formula of omega cross R. Let's just substitute them. We're talking about point B. Point B is moving on a circle about point O. So AT with the tangent component of B is going to simply be alpha, which question gave alpha to us. It is minus 2K. Let's move back to the question to make sure. Omega alpha OB, it says 2 radian per second squared, and it is clockwise. And clockwise, we know for us, is negative, right? So it is minus 2K. And similar to omega, it is K. It's coming out of a screen or going into the screen, which in this case, it's going into the screen, right? Because it is clockwise. This is alpha. So this is alpha, this is omega. Alpha is equal to 2. So that's about it. Cross R. We already found R. R was 0.15 cosine 60I plus sine 60J. Same R that we talked about it before. So this is all about tangent component. Now let's do the same things for N. N has a formula omega cross R. So omega is minus 10K cross minus 10K cross R. And R is going to be the same, cosine 60I plus sine 60J. So making sure that when we do the multiplication, we start with this one. Then we multiply it by 10K. Otherwise, we get 0, right? So remember, always we put a bracket here. All right, let's see what we've done so far. So all of these things that we calculated was ATB. All of this is ANB. And of course, this one is AA. So we need 2 more components, and let's work around them. So I need AT, A with respect to B, and AN, A with respect to B. The same. We use the same formula, except our R is the vector A with respect to B, this vector. Again, similar to before, right? This is R, A with respect to B. Let's substitute them. So plus, I'm going to continue over here. All right, so I need alpha, but it is alpha AB. This link AB, whatever alpha it has. And we don't know if it is positive or negative. We assume it's positive. I show it by K. Cross RA with respect to B. RA with respect to B, we found it before. It is 0.4 cosine. What was it? Let's move back. So this is here, right? RA with respect to B. Cosine and sine 20. Cosine 20 I minus sine 20 J. So this is RA with respect to B. And let's move this guy at the top. Right? Are we right? Yep. So alpha cross RA with respect to B, this is what we found is, right, this component. Oops. So this is AT, A with respect to B. And then getting to A normal, we use the formula. So omega AB, we already found it, right? Let's go back here. Omega AB, we have found it. We know the value and we know if it is positive or negative. So I assume that we found it. So I'm just going to write down it here. Omega AB K cross omega AB K cross RAB, which we know it is 0.4 cosine 20 I minus sine 20 J. Okay. So, and then this is our big bracket being closed. I told you it's going to be messy, but really it's, as you see, it's just some math. And this is ANAB. So if we can successfully add all these things and we can do all these crosses without making any mistake, we should be able to find two unknown that we have. Remember, when we have IJ, because we have two equations, one for I, one for J, if there are two unknown, we should be able to solve them. So one unknown is this AA, this is AA that we are looking after, right? The question asks us to find it. What is the other unknown? Can you guys see it? Because already I know omega AB, I found it before. So what is the other unknown? Yeah, that's alpha. Oops. This is what we are looking after as well, alpha AB. So we have two unknown. One is acceleration of point A. Another one is angular acceleration of AB. Remember, AB has a general motion. It rotates. So it may have also an angular acceleration. We already have found omega AB. So here from this equation, we can find alpha AB. And it is important also to find it because next chapter, you will see we need this alpha AB when we want to find out the forces at this joint A, B, and O. And you're wondering why we are calculating these, because we need to design the joint and bearing for this mechanism. Not in this course, in future. And in this course, our task is to find how much forces is on this joint A, how much forces is on this joint B or O. So knowing these forces in your next year courses, MEC 325, I believe, yes, 325, when you do the design for bearings, the assumption is that you know how to calculate the forces applied to a joint. In order to find the forces in a joint, which is the topic of next chapter, you need to know the acceleration, A. You need to know alpha, and then you will learn how you can use this information to find out the forces. Okay, so this is then, as you can see, we are building upon each topic, and it is important to follow them correctly. I just need a couple of minutes. So the same problem, now we want to do it using vectors, graphical vectors, and it is easier than velocities. Let's quickly do it. We just need to have our geometry hat and like old engineers and draw the directions and vectors correctly. So the good thing is that we know that point A, we know that its acceleration has to be on this horizontal line. So because now we have more components, keep in mind, now we need to draw like how many vectors here? 2, 4, 5 vectors rather than 3. So we need to carefully draw them. So this is the way that I do it. I draw a horizontal line and a vertical line somewhere. And carefully, I draw the component. Let's do that quickly. Okay, and again, for the direction, we don't care, but if we know the direction for one component, then we should do it correctly. But on which line they are, we have to be careful on that. So we know that VA has to be on this line, and let's for now assume that it is going positive. So this is AA. What else we know? Let's look at AT. Do I know ATB? So remember, I'm looking at this box and I'm trying to draw them now. ATB, let's look at point B. B is moving on a circle. We know it has to have 2 acceleration. One is tangent, which is always normal, sorry, which is perpendicular to that line, and one has to be on this line. So if I draw that line over here, and this angle is 30, because this angle is 30, then okay, this has to be my AT. B. Remember, when a point moving on a circle, right? Point B is moving on a circle, rotating on a circle. So the tangential component is a line being tangent to that circle. What about normal acceleration of point B? We know point B, its normal acceleration is toward point O, right? So then if I draw another line, oh, I need a lot of line then. So this is, oh, it's getting late. So this is a perpendicular line here. And we don't care about their length. We just draw them, their direction correctly. So this is A and B. I'll give you just 10 seconds to think about it and see if I haven't done any mistakes. So we are drawing the acceleration for point B. Point B is moving on a circle, right? And if it's moving on a circle, then it has 2 components, AT and AN. AT is tangent to that circle, and AN is a vector going to the center, point O. So this is AT, and this is AN. And we know this angle has to be 30 degrees, and this angle is 90. Then this angle has to be 60. So we've done that. We need 2 more. What is ATA with respect to B? I'm trying to draw these guys. A with respect to B. So we know how to visualize it, right? A with respect to B means that things are rotating about point B. So point A is moving on a circle, right? When we fix point B. And therefore, it has to have a tangent acceleration on this line and a normal acceleration on this line, right? Why? Because now we fix point B. Remember, we're talking about A with respect to B. So we know that A normal AB is on this line, and AT, A with respect to B, is on this line. All right. So where are those two lines? Let me draw them quickly here. Do I have another color somewhere? Yeah, maybe here. So this is that line. And its angle is 20 degrees. So this angle is 20 degrees. And then another line perpendicular to that, right? We're almost done, guys. Sorry for it took longer than I thought. Okay, so then simply what I will do, I say this is a normal AA with respect to B. And if you get confused why it is on this line, this is that vector, right? AA with respect to B means we join point B to the ground. So this has to be a normal acceleration of A with respect to B, because A is moving on a circle with respect to point B. We fix point B. And what is this tangent acceleration? It is its tangent acceleration. ATA with respect to B. And please notice that I don't know their direction. I just assume one direction and I let math to find out if they are negative or positive. And this is AN with respect to B. So what do we do with this information that we have? It's just vectors, and we have some information, and these vectors, they are balanced. And you know from physics, or you know from your MEC 260, if you have a bunch of vectors and they are balanced, then some of the vectors on X and some of the vectors in Y must be 0. Vectors in X is 0, some of the vectors in Y are 0. So try to find out the components in X and Y, and then you can find out the unknown. You're going to get two equations and you can solve them. I'm going to stop here, and then we're going to solve another example next lecture to make sure that you understand this topic. Okay? So rather than rushing it today. So if you guys have questions, I can stay in the room, if, or we can stop here and then we continue next lecture. Somebody has a question? No, you're good? Okay, see you guys then in next lecture.